So welcome everyone to lecture number 7, Foundations of Language Technology. Today we're going to talk about the first part of a 2-lecture series on part of speech tagging. So first of all, what you can do in this week, you can recapitulate the basic stuff that we've done in the last week, including the NLTK book. Now, again, let's have a brief look at what we've previously been doing in the last lecture. The last lecture was about dealing with HTML, working with files, opening files, and writing and closing files. We've seen regular expressions, and we did some experiments with regular expressions, and in particular applied this to some NLP problem, such as the finding of the stems of words. And as I said, in this lecture we're going to start out with a 2-lecture series on part of speech tagging in NLP, in natural language processing. So let's go into this right away. How do we categorize and tag words? So let's assume you have a book and you see a word in there, and now you want to attach some label to this word, and then maybe store that somewhere in your file. You will store the word together with its label. And the process of classifying words into their part of speeches, POS, is also known as part of speech tagging. Part of speech may be a little bit of a curious phrase. It's also known as word class or lexical category. In German, part of speech also translates into Wortart. And a collection of part of speech tags that are available in a language or in some domain are also called the tag set. And behold that the word classes, that is the part of speeches, depend on the context. So if you have a word such as can, then depending on its context, it can have a different part of speech. In this case, could either be a verb or it could be a noun. There are existing part of speech taggers. There are many out there because part of speech tagging is a very basic and very old problem in natural language processing and also, of course, in linguistics. And here's how you would use them. You have your text, and when you use NLTK, you can say, please tokenize this text. So you do a tokenization as we have seen in previous lectures. And then you can say, please pause tag the text for me. And what it will give you a list of pairs, and each pair is the word or the token, to be more precise, the token together with its part of speech. In this case here, if we want to look into some special cases, then we see that the first token here, and, is what is called CC in this tag set, namely a coordinating conjunction. So it's a conjunction which coordinates like two parts of a sentence. RB stands for adverb. For is a preposition which is denoted by IN in this tag set. Something is a noun in this tag set, or in this for this part of speech tagger. And for example, different is a JJ. That's also that's what we would call an adjective, right? And there are other things here. I know actually that covers all of the cases. So we have seen our tokens together with their part of speech labels. And the problem is difficult as I've shown on the previous slide, because you cannot just take a lookup table where all of those associations are stored, but it may really depend on the context. And it's important to know what is given down here, that for English automatic taggers, part of speech taggers, often do have very high accuracy, like on the level of 95 to 98%, so they are very, very accurate. and especially for English, which is a rather simple language for part of speech tagging, and also doesn't have too much linguistic variation, and especially nowadays that we have like all those neural taggers, so we really come very close to like the human upper bound, and behold that the human upper bound will also not be much higher than, let's say, 98%, because even humans will disagree on the status of certain words in certain contexts, and even if those humans are experts such as linguists. So nowadays for English, we come very, very close to what is possible from a human perspective in part of speech tagging. The documentation about tag sets is provided if you go to NLTK help and you type in, let's say you choose the UPenn tag set and you want to find out what does RB mean, or you go to the Brown tag set, you want to find out what does NN mean, and there are different NNs, so you can query for those different NNs and you will get a small documentation, and maybe there's even a README associated. Ambiguity, so that's what we've already talked about. Words with the same spelling might have different part of speech tags depending on the context. That's the previous example with can that we've seen. Here we see another instance for the word refuse. So I read out a sentence here. They refuse to permit us to obtain the refuse permit. So we have the same spelling here, but we have different part of speech tags. Namely, one times it's a verb, so this is a VBP, stands for a verb. I mean, they are different. This is a verb with a special particular subcategorization. This here is also a verb which lacks this subcategorization P here, but basically that's a verb. And the second one here stands for normal noun, so this is just a noun. And this ambiguity makes the problem difficult. If you want to check tag corpora, then you can get a list of token pos pairs in tag corpora and NLTK using the tagged words method. And note that not all corpora have POS tags. So we can go back to check. Yeah, so here it was pos tag. So this is because, so the difference here is here we tag a completely new text, and here we have an existing corpus which is not new, but it's stored in NLTK, and you access its token pos pairs using this using this method here. If you want to read tag corpora, you can access the tuples directly by typing in this tagged words method on the corpus that you're checking for. And now when we talk about tag sets, a tag set contains all the part of speeches that are available in a specific corpus. For example, one element in this tag set could be VBD, which could stand for verb in past tense. And this, of course, depends on the tag set that you have, right? Some tag sets may not distinguish between verbs in past tense and versus verbs in present tense, but they will only have a tag set, let's say V for verbs. But in this case, this particular tag set that we would be dealing with, let's say it has such a tag for the situation of verb in past tense. In practice, most tag sets that are used in NLP, they have lettercase letters, and if two tags are similar, they often start with the same initial letters. Let's say V stands for something that's related to verbs. It is important to note for you that tag sets are language specific and corpus specific. So German would have a different tag set usually than English, or like Turkish would have a different one than any of those two languages. And also if you have like a different corpus such as social media, you might have a tag for emoticons which you would not have in a newspaper text from the 1980s. There's also something which is called Universal Tag Set, which contains about 12 coarse-grained tags that can be used for a big set of languages. So I think the inventors of this universal tag set had in mind that there's like a commonality, the smallest common denominator, so to speak, between languages, and this can be boiled down to about 12 tag sets. So here's how this universal tag set looks like, together with some examples. So we have adjectives, abbreviated by ADJ, and examples in English are new, good, high. We have adposition, which are like prepositions. Yes, preposition or postposition. Postposition. So in some language, we also have something like postposition. That would be subsumed under the word adposition. Adverbs, conjunction, determiner. This is like articles, the, a, some, etc. Nouns, numbers like 24, Forbes, 1991. Particle, so this is like a rest category where things that end up with that, that cannot be classified right away as something else. We have pronouns, he, their, her, verbs, punctuation marks, and then a real rest category like particle is a linguistic rest category, but here the other category that is that may be other stuff that is not easy to classify in a language. It could be it could be something like emoticon, could be in the other class. It could be foreign language material, etc., etc. Or like slang or something, right? Where it's not exactly clear which category it satisfies. If you wanna, let's say we wanna determine the most common tags in a language, so we go to the pronoun corpus. Let's say we use the pronoun corpus. We get our tuples of words. We get our tuples of words and pairs. So in the pronoun corpus, we go in this nous corpus. Subcorpus, we're gonna go for the universal tag set, and then we make a frequency distribution for our tag corpus. So we go. So what we do is we have like we go over all word tag pairs in our list of pairs. We take the tag out of there and then make a frequency distribution. So we find out what is the most frequent tag, and then we're gonna check the 10 most frequent tags, and then we just say okay, what are the most common n ones here. So you would type in n, I guess, as an argument. You would get the 10 most common tags, and you can try this out for yourself, either in practice class or in the homework, or just by yourself on your local computer. So let's look at a few word classes, at a few part of speeches that are very common. So we have and this is like really, that's things that you learn in school, right? So nouns describe things, for example, persons, places, animals, objects, states. And now, so what are typical nouns? Like man, so that's a person. Cat, that's an animal. And it could also be something like economy, so that would probably be an object or something, right? And now let's confirm the assertion that nouns occur after determiners or adjectives in English, right? So let's do some coding in NLTK, and we wanna check that in English really nouns come after determiner or adjectives. So what we're gonna do is we go in our tag corpus. We're gonna check the bigrams, and then for each bigram in the pair, we check if the second one is a noun, right? And we make a frequency distribution. So if B, so each each bigram. So if the second one is a noun, which we're gonna check out what is the first, right? And we take the part of speech tag of that. And then we're gonna look at the most common things that precede nouns. And what we're gonna see is that could be another noun, it could be a determiner, it could be an adjective, it could be an apposition. So these are the most frequent ones. So typically noun is like in English that could be like let's say a discipline. No, that's not a it's not a good example. That could be cat woman, right? Or it could be, so you could also spell this as one word, but um, uh, the man endeavor, something like this, right? Where you have like two nouns that constitute one composite noun. Determiner noun is where you just have an article in front of the noun, like a woman. Adjective is a beautiful woman, and adposition, that's an well, give to children, right? So these are the most frequent things that come before a noun in English. Okay, so and now could we confirm the assertion that nouns occur after determiners or adjectives? Uh, well, not exactly. We've done something related, but still it gives us some clues or some hint that this statement is oftentimes true. About verbs, verbs describe events or actions, and actions such as fall, eat, etc. In a context of a sentence, verbs typically express a relation that involves the reference of one or more noun phrases. So you would say the cat is eating fish. So you have two reference, namely the cat and fish, and they are given as noun phrases. So they consist of they consist of nouns and like the surrounding material of nouns. So that's what we call a noun phrase. For example, the cat, right? So this is a noun phrase. It consists mostly of the phrase cat, but it also involves um, an article. And if we say the cat eats, or the cat is eating nice fish or tasty fish, so tasty fish would be another noun phrase, which is at the same time is a referent, and the verb connects those two. So the verb says how these two objects, how these two referents are connected. And if we want to check for the most common words per tag, how would we do this in NLTK? So we would go to a tree bank and to our tag words. We're going to check the universal tag set. We make a conditional frequency distribution over the list that contains all tags and words for a tag word in our tag corpus. And then in our conditional frequency distribution, we're going to check the verbs and check the most common ones, right? So we have a frequency distribution, but conditional on the part of speech tag. So we're gonna check our most common verbs, and you see in English, at least in this corpus that we have here, is, said, was, etc. are the most frequent ones. Let's go to the next class of the next word class. Adjectives are very common. They modify nouns. So you can have an attributive use, the large pizza, versus a predicative use, the pizza is large, right? So there are those two common use cases, at least in the classical languages that I know of, and probably also in many other languages. As for adverbs, they modify verbs. They do not refer to nouns, but to verbs. So, for instance, in the case the stocks fell quickly, or they may also modify adjectives, as in the case the teacher was really nice. And there are many other post tags in English. English has what we call closed word classes. So these are determiners, pronouns, preposition, and modals. Why are those closed? So there's a distinction between a closed and open word class. A closed word class is one where typically no new members enter. So you have like a couple of determiners, but they do not change quickly over time. Like they are certainly stable over 100 years, at least like 10 years, 20 years. And the same goes for pronouns, prepositions, and modal verbs. And the open classes, in contrast, like verb, adjectives, and nouns, they can really get new members as the language changes. And this is especially clear for nouns, where you have like a new noun, like when you have a new invention, for example, right? When people start to invent the computer, they need to give it a name. But also like it's the same with verbs, right? You invent new verbs as new inventions come along. For example, the word Google, right, can be both a name, a noun, or a verb, and this enters a language and enters the class of verbs or nouns. And when you want to classify those here, then, well, it depends on the language, on the dictionary. Well, yes, of course, yeah, different. So I'm not sure what to say about this. Okay, so let's more or less ignore this. Of course, when you wanna classify those, when you wanna give those things a part of speech tag, it depends on whether a language has a preposition, for example. So there are some languages which may only have postposition, so it's language dependent, but other than that, I'm not exactly sure what is meant by this statement here. If we can look at the Pantry Bank Tax Set, this is a tax set specifically for English. So the Pantry Bank is also like a special tree bank where you have, like, it's a corpus, and it's a classified or annotated corpus. Like it has categories, and it contains a lot of it contains also like a lot of annotations, right? This can be part of speech tags. It can be dependency parsers, what we're going to see in the upcoming lecture. So there are a lot of human annotations, classifications in there, and here's the text set that it has for English, and the Pantry Bank is an English data set, so this text set is specifically suited for English. For example, here you have VB set, which is verb third person singular present. So this is like when you add the S, like speaks, speak, and speaks. And you have this in English, and then there's VBP, which means non-third person. That's all the rest, right? If you would have a different language than English, let's say German or Czech or Turkish, you'd have many more such categories. But for English, you basically only say, is it third person or not third person? You can also have past participle. What is past participle? That's something like shown or spoken, right? That's past. You have gerund, like speaking. You have the base form, that is speak, and you have the past tense. And that would also be something like spoken, right? So I'm not exactly sure here what is the difference between past participle and past tense, but in any case, those are the categories that we have, and they are sufficient for English, and that's why they're used in the Pantry Bank. If we'd have another language, we'd have a bigger text. So to finish this part of the lecture, let's do a little bit of exploration of tagged corpora. So for example, let us study the word often, and we want to find out the word often, which part of speech are actually, which part of speech to the right neighbors. So we check the words to the right of the word often, which part of speech do they have? Like intuitively, we'd say something, often I'd go often I go to the cinema, so that would be either punctuation like a comma, or it would be a pronoun, or I do this very often, and then there's a punctuation, or yeah. So we'd guess there's gonna be a lot of punctuation, but let's do an exploration. So we're gonna go to the prawn corpus. We're gonna get the tagged words and in the universal tag set, and we're gonna use a specific subset, like a specific corpus of the prawn corpus, namely that is called learned here. Now, now we're gonna make all the bigrams in our list, in our list of words, together with their part of speech tags. So we're going to make the bigrams. So these are just pairs of consecutive items, and those items are now words together with their part of speech tags. Then we're gonna overall pairs. So this is the word that's the part of speech tag, and we're gonna no, this is the first item, and that's the subsequent item, and these are pairs. So we have a word, so 0 is the word and 1 is the part of speech tag. So we're going to check if the first word is often, what's going to be the part of speech of the following word, right? And again, we're going to do this. So this is just this all the part of speeches of the words that follow the word often. So we're going to do a frequency distribution. We're going to tabulate this, and what's coming out is verbs are most often coming after the word often, then adverb, adposition, adjective, and punctuation. So, and you see that this is a very small sample, so there are hardly 50 or 60 instances, and what we've been guessing, like the period that the word often stands at the end, is actually not very frequent here, but we have the verbs coming after often. So that's something like I often like to swim, or I often I am often laughing, or something, right? So in this corpus we have mostly verbs, and no nouns coming after the word often. Another thing that we might want to find out is, and that you can explore for yourself, also like in self-study, is something like finding words that involve a particular word tag sequence. For example, we want to have a verb and then to, and then another verb, such as in like to swim. So that's verb to verb. And here, how can we find that out? So we're gonna go over like, let's say we're gonna go over tagged sentences. Then we process each sentence, and then we're gonna check trigrams in the sentence. So trigrams are in this case it would be so that's 3 subsequent items, each one consisting of a verb and its part of speech tag. And then we're going to check if the first element is starting with a V. So we're going to have a verb, something like a verb, could also be a subcategorization of verb like VB set. And the second element, so is to. So here we could also query for the verb itself, but I think here what they are doing is they're checking the part of speech, the part of speech tag, which in this case is just TO, so capitalized. And the third element again starts with a V. Then we're gonna return this one, or we're gonna print it out, right? And then we're running over all our sentences, and then for each trigram in this sentence, we're gonna print out our desired pattern if we find it, and then we're gonna find something like combined to achieve, continue to place, serve to protect. And here we see that this is like past tense, because we allowed that. We just said, okay, if it starts with a verb and everything else can be different categories, such as verb in past tense or something. So you could modify this to find, for example, only present tense cases. So let us finish up with our small programming exercise on part of speech tags by checking the ambiguity of words. And like, ambiguity means how many in this context, ambiguity means how many different part of speech tags can a word have. So what we do for this, we go to our Brown corpus. We're gonna take the categories news, and we're gonna use the universal tag set. We then go into all word tag pairs in the Brown news tag corpus. We're gonna lowercase the word so that our investigation is case insensitive. We're gonna take this list of pairs as argument to conditional freq dist of NLTK, which gives us a conditional frequency distribution for each word. How often do the tags occur? Then we go over the conditions, which are the words. Let's say we're only gonna consider words that are long, right? Let's say they have more than 3 characters. Then we're gonna look at the tags. So we could again check the most frequent tags, but in this case we're not gonna sort by frequencies, but we're just gonna look at all of them. And remember that data word, this gives an object which is resembles very much a dictionary. So we take the keys of this dictionary, which are then the tags, and then we're gonna print out the information. And we see, like, in this case, this prints just a small subset. We see that the word close has 1, 2, 3, 4 different ones, and all of those words gonna here that we have 4 different ones. Now we can wonder what 4 different ones do they have. For example, present, that's a verb in the context of let me present to you something, so it's a verb. I got a nice present. Then it's a noun. In the present days, it's going to be an adjective, and in other contexts that you yourself can think about now, it's going to be an adverb. So we see that really this could be a difficult task, then namely depending on the context in which words occur, they may take on different part of speech classes and part of speech tags. So with this, we have our take-home message. We've seen part of speech tagging to find word classes for words. We saw that there are tag corpora that already have part of speech tags for all the texts in the corpus. We saw how to do automatic part of speech tagging, at least in one example, and I've also told you that this is a task which is relative, even though we said it's difficult, but the current techniques are strong enough, and the task is, even though difficult, not in such a range of difficulty and not on such a level of difficulty that the current methods fail, but in contrast, they come close to the human upper bounds and the human performance. We've also seen different tag sets, so the universal tag sets, and then language-specific tag sets, such as the Pantry Bank Tax Set. And we've seen a little bit of functionalities on part of speech tagging, on how to extract, let's say, common tags for a word, and also how to obtain the different word classes that a word can have. And why is that all of that useful? Because it gives insights to corpus linguistics. How do we use language? Which word classes exist? Which patterns are there? Which kind of ambiguity? It's also important for doing pre-processing, to remove stop words, for example, because we can get the stop words by the word class. For example, if they are punctuation, we could remove them. and that could be given by the part of speech tag. We could also use that for keyword extraction. So nouns are usually keywords of a document. For example, if you have a scientific paper, they usually take the nouns and verbs, maybe mostly nouns, as the keyword. So by doing part of speech tagging, we can approximate this, or we can at least we can exclude other candidates. And well, we can also use that for text analysis, um, as given in the example down here. So we have Mary gives John the book, or Mary passes the book to John. And now what we have in this case is we have that we have that something changes the ownership, namely the book goes from Mary to John. So this is the relationship, and we see that those three candidates here, they are written, they have the same part of speech tags, even though the verb changes, and here also we have a like a preposition coming in, or like a particle coming in, and even though we have this, the meaning changes the same, and maybe we can see that the relationship between those elements stays by considering the part of speech tags, which remain constant over the two realizations. Here are some useful links, for example, the Pantry Bank Tax Sets, guidelines how to do part of speech tagging, and then there's also, like in other languages, there are also part of speech tags and word classes, such as the Stuttgart Tübingen Tax Set STTS, which is like a quite old one, like I think at least almost 20 years or maybe even older tax set for German, and there are also special tax sets for other languages. And now we go to the second part of speech tagging.